Hey, this is Mr. Word. I'm going to be talking about Chapter 4, but in order to talk about Chapter 4, I want to go back to 3.7 in Chapter 3, number 16. Number 16 illustrates a key concept of Chapter 4. Chapter 4, we start off in Chapter 4 with the concept of a detour problem. And a detour problem happens when you are trying to prove something, but you have to prove another triangle. Like maybe you have these two triangles that you want to prove, ABE, and ADE. You want to prove they're congruent, but you don't have enough information to prove them. But you do have enough information to prove another set of triangles are congruent, which will lead to a kappa, which will lead to those triangles. So it's a detour. So to illustrate that, we kind of previewed this one with chapter 3.7, number 16. And so when we look at chapter 3.7, problem set D, there's this question 16. And we've got this, what looks like a parallelogram, and probably will be a parallelogram once we prove some things. But we are told that DT and RK are congruent. So let's just start labeling things that are congruent. We knew that DT and RK are congruent. We also know that DE is congruent to KV. And then we're told that ERV and VTE are right angles. So what is that? ERV, so that's a right angle right there. And we also know that VTE is a right angle too. All right, with that information, what we can do, well, first of all, let me just see what we have to prove. We have to prove that ER is congruent to TV. Right now, we do not have enough information for that. We do not know what these angles are here, and we don't know if these sides are congruent, so we don't have enough information. So if we wanted to figure all that out, it would probably be useful to draw an auxiliary line. So I'm going to do that. I'm going to draw an auxiliary line. What I'm going to do is I'm going to do a line that E to V. So I'm splitting that like that. Now, by drawing that auxiliary line, now I didn't have enough information to prove ER and TV are congruent. I definitely don't have enough information to prove that DR and TK are congruent. So I have to do a detour. My detour is prove that ERV and VTE are congruent triangles. I think I do have enough information for that. I know this and this longer thing are congruent. I know this short thing and this short thing are congruent. So if I could use subtraction to prove that RV and ET are congruent, then I'll have, and I know that EV is congruent to itself, I'll have a hypotenuse leg proof that I can use. So I can do that. I can prove that RV is congruent to ET by subtraction. If I subtract congruent things from congruent things, I will get congruent differences. So RV and TE are congruent. I also know that EV is congruent to itself by reflexive property. And now I have a leg and a hypotenuse, and these are right triangles by virtue of having a right angle. So I can use hypotenuse leg as a theorem. So hypotenuse leg will get me to ERV and VTE as triangles are congruent. Now, once I have that, I can prove that ER is congruent to VT by kappa. So I can use, okay, so let's say this is congruent to this because these two triangles are congruent by kappa. Now, once I have that information, now I may be able to prove that, let's see if I can prove if I have enough information to prove that DR and TK are congruent. Now, I believe I have enough information. Let's take a look. So I now have this side and this side, this side and this side. Now, do I have... Okay, so let's consider this. Okay, we're going to have Kapakatika come in for the rescue here, because we could actually prove that now that this angle and this angle are congruent, and then we can prove that this angle and this angle are congruent. Okay, so I could add these two together and I'll have a congruent sum. Once I have that, then I've got this congruent sum where I can say, overall, this is congruent to this, and this is supplemental to this. This is supplemental to this. And because of that, I now have just gotten enough information to prove that this angle is congruent to this angle. And since this side is congruent to this side is congruent to this side, and this angle is congruent to this angle, I can prove that DR and TK are congruent by angle, side, angle. And we're done with that one. And the next, I'm going to go on to chapter 4 and talk more about detours. Just to recap, what I had to do to prove ER and TV were congruent was that I had to prove that these two, I had to create by drawing an auxiliary line and go on a detour to prove that these two triangles are congruent. So I could use Kapakatika to prove those sides are congruent. And that led me to ways to prove that DR and TK are congruent by proving using these triangles in combination to prove these angles were congruent, so that I could then use the givens of DE and KV being congruent in order to prove one last thing, which was simply that DR and KT were congruent. So that's an example of a detour problem. Now I'm going to go into chapter 4 where we actually directly talk about detour problems. So, and there's a procedure for detour problems. So let's look at this very first one. We are supposed to prove that ABE and ADE are congruent. Okay, those are the triangles we're supposed to prove are congruent. We're given some information. We're given AB is congruent there to AD, and they're already marked up. We're also given that BC and DC or CD are congruent. I would prefer to call it DC because it keeps it in corresponding order. Okay. Now, that's not, this side here and this side here is not enough to prove that ABE is congruent to ADE. However, we do have enough information to prove that a couple larger triangles are congruent. We can prove that ADC is congruent to ABC. Okay, and we can do that by side, 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 because we can prove that AC is congruent to itself by reflexive property. I'm going to use the eraser so I don't lose that there. Okay, but AC is congruent to itself by reflexive. So we can now prove by side, side, side that ABC is congruent to ADC. Okay, and there it is, side, side, side. So we got the givens. We got AC is congruent to itself by reflexive property, and therefore ABC and ADC are congruent by side, side, side. And then we, because of that, by Kapakatika, we can now prove that this angle here and this angle here are congruent. I drew that really big, but hopefully you can see what that does for us. So now BAE and DAE are congruent, and AE is congruent to itself again by reflexive property. And so now we have a side, side angle, side, side angle, side proof that we can use. We had to follow this detour first in order to do that. We had to prove that these larger triangles were congruent in order to have enough information to prove that ABE and ADE were congruent. Okay, so let's take a look at a couple more. Actually, let's talk about this procedure. So there is a procedure that's recommended by this textbook that I think is very sound. Okay, so I think this is a really important thing. So I'm going to underscore it. So here it is. We're going to start, determine which pair of triangles you want to prove for congruent. Okay, and see what they are. See where you're heading first. Then try to prove those triangles congruent. If you can't do it, if you cannot do it because you don't have enough information, take a detour. And then you want to figure out which congruent parts are needed. Now remember, we've got side, side, side we can use. We've got side, angle, side, angle, side, angle, so side, angle, side. We've got angle, side, angle. And we've also got hypotenuse leg that we can work with. Later on, you'll learn about one called angle, angle, side. We don't have that yet. We have these tools in order to work things out. Okay, so look for what things you might need. Then see if you can find another pair of triangles. Find another pair of triangles that you can readily prove are congruent and contain a pair of missing parts that are needed for that proof. Okay, then once you have found those other triangles that would contain the pair of missing parts you need for your main proof, prove those triangles are congruent, just like we did in number 16 from 3.7. Okay, once you have that information, then you can use kappa kataka to declare those parts congruent and then complete the proof as needed. Sometimes you're going to need to do more than one detour in a problem. Okay, but let's take a look at a couple of sample problems. Okay, here we want to prove that angle WQP is congruent to angle XQP. All right, in order to do that, it would be helpful to prove that these two triangles are congruent, this WPQ and XPQ. All right, but do we have enough information? We know that PQ bisects YZ, but we don't know that it bisects WX yet. Okay, from that statement, we know, but that gives us that XP and YP are congruent. We know Q is the midpoint of WX. Now we know that these two sides are congruent, WQ and XQ. And then we're told that angle Y is congruent to angle Z, and they're labeled up here. That's nice. And WZ is congruent to XY. So this side and this side are congruent. Okay, in order to prove that these triangles are congruent, in order to get these angles congruent, you need these triangles congruent. You're going to need to prove the other one. Okay, so as you can probably tell, I'm being interrupted as I make the video, but I wanted to get this video done, so I'm going to keep going. So what I've said is we need to do a detour from proving that angle WQP is congruent to angle XQP, because we don't have enough information to prove these triangles. But if we could prove WP and XP are congruent, then we could prove these two triangles are congruent. We have a side that would be reflexive, and then we would have a third side, and then it would be side, side, side for the proof. So let's take a look and see what the other triangle is. We can prove WZP and XYP are congruent because we have side, angle, side available to us. So there we go. Once we've done side, angle, side, we have enough information to then prove by kappa kataka that WP and XP are congruent. We know this is congruent to itself, and then we can prove side, 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 and then from side, 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 we can prove that this angle is, and started to get a little ahead of myself, that this angle is congruent to this angle. And we're not asked to prove this, but the fact that these two angles, which are supplementary to each other, are congruent to each other, that'll actually lead to them being right angles. But that's not something we're asked for. We're simply asked for proving that they are congruent. So once we prove side, side, side for these two triangles, then we can use kappa kata to prove these angles are congruent. Well, let's take a look at one more detour problem, I think. And we've got all that stuff laid out here for you. You can review that proof and see if they match what I came up with. It probably does. Okay, now here we've got AB is congruent to DC. I would say CD probably. And then AD is congruent to BC. I would say CB in this case. All right, so we have those sides and those sides being congruent. Now we know that AE bisects BAD, and we know CF bisects DCB, or BCD as they are saying. Okay, if we know that that bisects those, then we know that there's a couple of triangles here and here that are congruent, and a couple of triangles here and here that are congruent. Okay, so we're trying to prove that ED and FB are congruent. I'm calling it FB. Now, if we could prove, we don't have enough information right now to prove those, but if we could somehow prove that BFC were congruent to DEA, then by kappa kata we could prove those two sides are congruent. Okay, but we only have this side and this side congruent. We don't have anything about angles yet. We know that these angles are bisected, but we don't know that these angles are the same. So here's what we need. We need to prove that ABD is congruent to CDB. If we can prove that, then we could prove that this angle is congruent to this angle, and I think we'll have what we need. So let's start exploring that. Well, we can prove these triangles are congruent because BD is a shared side for them, so that's congruent by reflexive property. And this is how they do it. This is the detour they take. The book takes the givens. AB is DC, AD is BC. Those are givens, and then BD is itself by reflexive property, and therefore triangle ABD is congruent to triangle CDB. Okay, by side, side, side. Now we can then prove a couple of things. We can prove that angle ABD is congruent. So let's label that. We can prove that this is congruent to angle CDB. Okay, so hang on a second. We can prove that angle, I've gone out a little out of order here. So angle ADB, let me back up for a second. Get rid of that for right now, and we'll label it differently. But it actually doesn't matter. We could have done it either way. So ADB here is congruent to CBD by kappa kata. And then we can also prove that these other angles on the other end are congruent. Let's see. DAB, well, we can prove DAB is congruent to BC to DCB or BCD, either way. We could also have proven that this angle, the proof may not require it, but we can prove that this angle is congruent to this angle. That's not actually part of the proof that the book is using, but it's true. I'm just labeling everything so I see what I can work with. All right. Now we were given, since we've been proven that this angle and this angle are congruent, we were given that AE bisects BAD, and we were given that CF bisects BCD. All right, if we want to prove this side here is congruent to this side, then it's probably better for us to focus on this triangle and this triangle. Okay, and because these are sides of them. All right, so since this is bisecting here, let me grab a different color. Since this is bisecting, If I split congruent angles in half, then the quotients of congruent things divided by 2 are going to also be congruent. So now I have an angle, side angle, angle, side angle for these triangles. And that will lead me right there to where I want to be, which is that BF is congruent to DE by Kappa-Kadaka. Okay, so I've just proved angle, side angle, and then ED and BF are congruent by Kappa-Kadaka. All right, so that's what you're going to be working with. You're going to be trying to figuring out if you have enough information to prove 2 triangles are congruent. If you don't, then you're going to see what you would need and find triangles that you could prove congruent, and then use Kappa-Kadaka to prove the missing parts or the unknown parts are congruent. And that's called the detour. And then you'll prove finally that the triangles that you're looking for are congruent.